Welcome to the tutorial on numericals on step response of RC circuit. So let us solve some numericals on step response of RC circuit. So in this particular circuit, they have mentioned that the input changes abruptly from 5 volt to 0 volt at a time t is equal to 0. And we assume the source was at Vi for a very long time. So when they say the source was at Vi means the capacitor voltage would be the same as that of the input. That is because we have seen previously in the previous tutorial video that the capacitor will act like an open circuit and the voltage across the capacitor will be same as that of Vi. So here they say the source was at Vi for a very long time, which means the capacitor voltage also would be at 5 volt itself. And we need to find the expression for capacitor voltage as a function of time. That means after the source voltage changes from Vi to Vf at time t is equal to 0, what would be the complete expression for capacitor voltage? We have obtained or seen this particular expression in the previous tutorial, that the capacitor voltage can be expressed as Vc of t to be equal to Vf plus Vi minus Vf into e power minus t by tau, where tau is the time constant given by R into C for an RC circuit. So let me first find out what is the time constant looking at all the circuit parameters that are given. So tau on substituting, you have 2k multiplied with 10 nano, which is equal to 20 microseconds. And the question says Vi is equal to 5 volt and Vf is equal to 0 volt. So we have Vc of t is equal to Vi, that is 5 e power minus t divided by tau, that is equal to 20 micro. So this is the expression for capacitor voltage, and the value or the unit of this capacitor voltage is volts. The second part of the question says you need to find the time at which the Vc value is equal to 1 volt. So this particular value is 1 volt and we need to find out the value of t. So 1 volt is equal to 5 e power minus t by 20 micro. Now since there is an exponential term here, we need to take the ln. So let me take ln on both the sides. Before that, let me rearrange this. So this becomes ln of 1 by 5 equals, so when you take the ln, this term, exponential term, goes off and you have it as minus t by 20 micro. So on rearranging and substituting, the value of t will be equal to minus 20 ln of 1 by 5, which is equal to 32.2 microseconds. The negative term disappears because I can rewrite this expression as 20 micro ln of 5 by 1. So that is how I get the result as 32.2 microseconds.